hope we're all doing okay. So this is Unit 6 Classwork 4 on differential equations with ln and e, and this is Ms. Schultz. This is part 3, so we're going to go over problem 7 and 8, and then part 4 we'll do 9 through 12. Okay, all right, so let's go. Okay, so first question is, this is kind of like a warm-up to what you're going to have to do in the ocelot problem. Let me get my stuff figured out here. Okay, there we go. I gave you a little hint at the answer there. Okay, so go ahead for number 7. Just tell me what the answer is. Go ahead and integrate. Okay, let's do it out. Let me see, I think I got my tech all set here. So how you want to do it is you want to do ln of absolute value of the inside. Why? Because the degree of the denominator is 1, so that's how you know when the integral is ln, times the reciprocal of the derivative of the inside. When the inside is linear, you can use this trick, which is basically a shortcut to use substitution. So the derivative of the inside is -1. The reciprocal of -1 is -1, so you multiply by that. Okay? So that's that. That's our warm-up. Let's look at this beautiful, cute ocelot here. Okay, maybe we'll do a little bit of that. Okay. Okay, a little bit of that. Okay, so now let's read this problem. And for Q1, the rate at which baby ocelot gains weight is proportional to the difference between the weight, Okay. So here, the derivative is a proportion, aka it's linear. So that's the rate of growth of the weight. Okay, now we have this initial condition. I would annotate that, IC, if you would. That's what I would do. Now, A is not supposed to be like too much of a heavy lift. If the ocelot is gaining weight is the ocelot gaining weight faster when it weighs 450 grams or 600 grams? So I have gaining weight faster. That's a derivative. That's like a rate word. So you're just, why don't you try to answer this, and then we'll go over how to do it. Okay. All right, let's go over it. So how you do it is you just plug in. So you plug in each of these values, 450 and 600, and see which one's bigger. So when you plug in 450, you get 250 over 6. I didn't even bother to simplify that. And then when you plug in 600, you get 100 over 6. So therefore, which one of these numbers is bigger? That is bigger. So the ocelot is gaining weight faster at 450 grams because the derivative at 450 is bigger than the derivative at 600. Okay? And that makes sense. Little babies grow faster at the beginning and then their growth rate slows down. Okay, second one is find the second derivative given this first derivative. Okay, so this is called implicit differentiation. All right, I'm gonna give you a tip here before I set you loose to do it. To take the derivative of this, bravo, Darren, bravo. Okay, to take the derivative, my son Darren just won his game, Pac-Man. Okay, so to take the derivative of this, you want to distribute in the 1/6, okay? Distribute in the 1/6. And then at some point, you're gonna have to sub in for dB dt. Okay, so go ahead, see if you can do it. Alrighty, let's go over it. So I distribute. The distribution looks like this. Okay, so that's the derivative. Now the problem says in terms of b. So this is not in terms of b, this is in terms of dB dt. So I need to take, this is correct, this is second derivative, but it's not my final simplest form in terms of b. So I'm gonna take what dB dt is and sub in. So I used this version. You could use the original version that wasn't distributed, either way. So you could leave it like that. If you distribute it through, it would be that. So that, see how dB dt is this, right? And then, so I just took that and substituted it in for dB dt. Okay, and if you substitute in the undistributed version, of that, you know, you'd get positive 136th in front, kind of thing. That'd be fine. Okay, let's do C. C is the 5-step thing with differential equations. All right, so go ahead, use separation of variables to find y equals b of t, the particular solution of the equation with this initial condition. So why don't you go ahead and please just separate the variables and integrate, and then I'll meet you there. Okay, separate the variables and integrate. Okay. Let's see here. Okay, so here's it with separating the variables and integrating, okay? So again, this is negative because you multiply by the reciprocal of the derivative of the inside. Try to say that, multiply by the reciprocal of the derivative of the inside. Okay, so now what am I gonna do? I'm gonna start solving for b here before I plug in my initial condition and solve for e to the c. So what I'm gonna do is I'm gonna take this negative and put it up top and make it to the -1, all right? Like that. Okay, so I get this, okay? Now, I have to just do something with this negative. I could have divided by negative on both sides now that I think about it. But whatever, I did this. So now I'm gonna do e to the both, I'm gonna do e to the each side. So I get this, right? This cancels. So on this side I get that. I think I made this more complicated than it would be. I could have just divided by a negative on both sides now that I think about it. Whatever, this is what we're doing. Okay, so now, what did I do next? So now go ahead, plug in and solve for e to the c, please. Plug in your initial condition, which is 0,450. Okay, so I plug in, it looks like this. E to the c is 1/250. Okay, so I go ahead and so now go ahead and what's your final answer? It's a little tricky. Yeah, there's a couple different forms to do it. Yeah, there's a couple different ways to do it. Whether you get common denominators or just end up with a complex fraction, either one of those is fine. Okay, let's do it. So I put it back in and it looks like this, yes. So I just took this and I put the 1/250th in and I put it as a coefficient on the front. Now I'm gonna take away my absolute values and put a plus or minus in. The y value is 450, which is positive, so it just looks like that. And then I take the reciprocal of both sides, like that, okay? And now I can just legit subtract 700 and multiply everything by a negative to that and solve it. I get either of these two as my answers. So like this is if I just, you know, subtract 700 from both sides and take the negative of everything. This you could rewrite if you wanted as this with a negative exponent, right? And then everything would be down here, so this would be negative that minus 700. Yeah, and then if we, at this point, if we had multiplied by a negative instead of taking the reciprocal on the left, see, that's where I get my -1/6. So if you did it that way, you would have gotten this. Okay, let's move on to number 8. That was a really tough one, I must say. Okay, all right, tangent lines. I know some people have different feelings about these. All right, so write the equation of the tangent line. So let's see, can you do it from start to finish? Let's say first, just write the equation of the tangent line. That's what I'm gonna ask you right now. Write the equation of the tangent line. Let me see. Okay, so let's do it. So whenever I write the equation of a tangent line, I start here. Okay, so I got, the slope is the derivative, okay? So it legit just gives me the derivative. So to find the m, I just plug into what I'm given, okay? So I plug in, let me see, my initial condition, the x is 1 and the y is 0. So that means e to the 0 times, and I'm plugging in 1 for x here, right? So I get -3 as my m. And then, so I got my m, check. I need my x1 and my y1. I'm given both of these points. My x1 is 1 and my y1 is 0. So in other words, it's like this. Okay, so now please use this tangent line to approximate f of 1.2. Okay, let's go over it. So it's actually easier to approximate it if you don't distribute at the -3, because 1.2 minus 1 is simpler to do than something times -3. So this is my final answer, -0.6. Okay, so find the particular solution to this diffie-q with this initial condition 1, 0. This is our very first actually diffie-q with e in it. So I'm actually going to have to integrate e, which is going to be different. Let's start it together. Okay, so I'm going to separate the variables. So that looks like this, okay? Now, before I can integrate, I need to rewrite the left side. So think about how to rewrite the left side. Okay, so this is how you rewrite the left side. You need a negative exponent. So now when I integrate e, it's always itself, okay? And if my inside, aka exponent, is linear, then I multiply by the reciprocal of the derivative of the inside. So this is linear, so the derivative of the inside is -1. I multiply by the reciprocal of -1. So the reciprocal is as follows. The integral is as follows, like that. Okay? So now I want you to, so how far do I want you to go? Plug in and find what c is. Not e to the c, but this time we're just gonna solve for c. So I plugged in right here. Okay, let's do it. Okay, so I plug in and I get -e to the -1. So in other words, -1/e is my c. Okay, so go ahead, put that c back in and see, can you solve fully for y, all right? Can you solve fully for y? Okay, let's go over it. Okay, so I put this back in. Okay, now to start for solving for y, I'm going to take the negative of everything, okay, right? Now, how do I, if I have a variable in the exponent that I want to solve for, how I get it out of the exponent is I take the logarithm of both sides, or I rewrite it as a logarithm. Oh, so first I did that. Yeah, I didn't totally need to do that, but it's fine. So I take the, oh yeah, I guess, okay, that's fine. Yeah, you could have taken the log of both sides right here, but okay, cool. Why not? So I did it like this, where I rewrote this. I guess I'm big into rewriting. So I rewrote it as 1/e to the y, and then I took the reciprocal of both sides, right? Okay, cool. And now I rewrote it with ln, and so this just, when I take the ln of both sides, this legit just becomes y. Okay? And so this is your final answer. You can rewrite this as the difference of two logs. Okay, so that becomes 0, so like that would be your, what, you can simplify it to be that. But this is a fine final answer, but you could also just make it negative ln of the inside. Okay, and that's your answer. So yeah, I get these were a little tricky, but hopefully you were able to follow along. If not, please let me know. Yes, okay, thank you, bye. Oh, this is another alternate answer. You could rewrite it like that and then take the derivative, the ln, okay.